Okay, I think that's enough of building random 3D objects just because I can. It's time to get back to an LED lamp, an unusual LED lamp. But first of all, let me demonstrate one of my useless objects. So this is a packet of chocolate coins from Costa Coffee in the UK. And with a little bit of code, I've managed to create this terribly useful solid base with wings and countersunk screw positions so you can screw it down to a firm surface. Why? It's so you can store all your chocolate coins in a nice, convenient, accessible manner in the rack. How useless is that? But it's ultimately, when you get a 3D printer, you do things because you can. I'm just going to load this up fully with chocolate coins. I shall resist the temptation to eat a chocolate coin until after the video is done, just to make sure I don't make any loud masticating noises. But anyway, I've already digressed. Lots of re-entrant round objects and lots of angular hexagonal objects, because exploring that openscad, I know it's supposed to be called openscad, because it rolls off the tongue easier. The software is very good. Once you actually get to the grip of it, you can create quite complex things. Anyway, that's enough of that. I shall put my newly loaded rack of coins to the side. Let's take a look at this lamp. It's a 2-watt LED filament lamp, and the reason I'm pretty sure I got this at the time was I was suspicious that it may be based on really simple circuitry. It was very cheap, and part of the cheapness might be the fact that if you look up close, it's not exactly central, and eBay is, of course, a great place for getting rid of your rejects. So let's grab a lamp holder. Let's get the hoppy meter up, and we'll test this lamp, and I'll show you what's quite odd about it. Here is the bayonet cap lamp holder. I get the feeling this is going to be flickery. I've not tried it on camera, but we'll see what it's like. It's not that flickery. It says the power consumption. I say it's not flickery. Seriously, to me, that is flickery and the camera's not picking it up. That's interesting. The current is 11 milliamps. The power is 2.6 watts. The power factor is 0.94 or thereabouts. That is very weird. I feel the great need to open this lamp. Let's open the lamp. I'm thinking that it might possibly have no smoothing, because I saw quite a lot of flicker there. Best way to open this is probably to nibble my way in. Let's go down a bit closer so you can observe the nibblation. I'm thinking, although I could be wrong, I don't think there's smoothing. I get the feeling, oh, this is all going to go horribly wrong given what I've done so far. I'm going to end up nipping myself. Oh well, if it happens, it happens. I shall put it down there and get it started. I'm finding it quite hard getting in the first place. It is put together with traditional lamp cement, so that's not going to make life easy. As usual, if this starts taking far too long or I lacerate myself in the process, I shall pause. Some of you will be screaming, use a Dremel. The Dremel makes a huge mess when I use it. Like metal and stuff everywhere. Fine dust that gets into everything. When I use it at this bench, I could use it elsewhere. But this is my main bench. Right, this is kind of getting there. It's kind of getting there. I think I'm almost at the point that I've just broken the back of the task. And right, okay, this is unpeeling now. What's it going to be? Is it going to be a resistor and a rectifier, or is there going to be more sophisticated circuitry? I'm seeing a little sleeved thing, which could be a circuit. Well, it is a circuit board. I'm not seeing the resistor I was expecting. I could be wrong. Is it a little capacitive dropper? I should stick the soldering iron on. Yep. And I was just thinking, did I say the right thing there? Yes, I did. I could stick the soldering iron on, I could desolder the leads where they come out at the bottom here, or if it's successful I could just nibble, but that thing has just been pressed into the point. Right, give me a second. I'm just going to desolder this and then take a close-up look at that circuit board. Here's the little circuit board. The one side of it has a current regulating chip. It's not marked. I don't know what version that is. The other side has a bridge rectifier, and basically speaking, I should mention here, I flipped this image over, which is why the text is effectively back to front. It's just to make it correlate to this. So these contacts, like this corner, will be this corner of this picture as well, the other side. The main supply comes in, and it goes straight to a bridge rectifier. The positive of that bridge rectifier goes straight out to the LEDs. comes back from the LEDs, and then it gets regulated by this chip. There is a small capacitor, very low value capacitor. I measured this in circuit. It's not the best way to test circuit capacitors, particularly for other components in vicinity, but I think it was fairly clear. It came in at 1 nanofarad, so very low value capacitor. There is a 47R0, that's 47 ohm resistor, being used as a sense resistor. That's more or less it. Let me bring in the schematic I doodled. It's very simple. I could have actually closed it up. I left a huge void here, but not to worry. Let's zoom down and take a look at this. So what we have here, we've got the incoming AC supply, goes through the bridge rectifier. It then the positive goes through the two LEDs. I say two LEDs. By that I mean the filaments here, which have a stack usually of about 30 or so LEDs. So each one will be dropping about, say, 90 volts typically. So that adds up to about 180 volts dropped, with the rest being dropped across this little self-regulating chip. The regulating chip is notable in that it's a little 8-pin package, but it's actually got two regulators on board, and they've just timed them in parallel. That might be to spread the dissipation across the whole package. The 1 nanofarad capacitor is going across that package, so its function is purely to limit any transient spikes that might cause the transistors in here to get upset. It's using that 47 ohm resistor. What actually happens here is the current goes through the LEDs, goes through the chip and then through this resistor. And as the current gets higher, the voltage across that will rise up. And without knowing exactly what component this is, I'm going to guess at 0.6 volt. Typical transistor forward voltage drop is what is probably being used here. And if we do the arithmetic, if we bring in this sissy squad calculator, and we work that out, the current that I measured flowing through the LEDs was around about 11, 12 milliamps. Let's check this. So I equals V, 0.6 volts, 0.6 divided by the sense resistor, 47 ohms, equals 12.7 milliamps. So that's almost certainly it. It's probably a 0.6 volt sensing threshold. And what really happens here is that it acts as a variable resistor that just regulates up and down, but it's got the extra benefit, well, most of these things have the extra benefit. If it starts getting too hot internally, it will self-regulate. It will actually override this resistor, and it will start regulating the current down till it reaches a thermal equilibrium point. So it's not what I was expecting. This tiny little circuit board inside, I was maybe just expecting the rectifier there. I was kind of, I was expecting this maybe on a tiny circuit board and then some surface mount resistors or one big resistor. But instead, it's just this electronic sense chip, this current regulator. So it's interesting. The reason there's flicker, well, visible flicker to me, but it didn't pick it up in the camera. It maybe did a good job of detecting the 50 hertz. The reason for that is simply because it doesn't have a smoothing capacitor. I think this tiny little circuit board is just the minimum possible they could have got off with. It's designed for going into really tiny bases like the E14 base or smaller, where they can just shove that in, and that's where an electrolytic capacitor then adds a lot of space to it and probably reduces the reliability, the reliability. So there we go. Not what I was expecting. What I also found out, I managed to jab myself with it. When I took the base off, the dark base on the bayonet cap lamp holder, hold on, have I got one here? Yeah, but this one's plastic, I think. But the one that was on this, oh, and can I say, the hardest bit was getting it desoldered, because the solder was really high temperature, like even higher temperature than normal sort of lead-free-ish type solder. But this is the soldered ends, and what was basically a dark glass, like a brown beer bottle type glass, was the type of insulation at the bottom. So that just alludes to the fact that this lamp has been made at the place that manufactures standard lamps, and it's just this is their evolution to the LED filaments. But there we go. It was well worth taking apart. It was very interesting inside.